All right, so what we're looking at here, guys, is a question from 2018. The reason why I think this problem's a little bit more difficult is that this is supposed to be done without a calculator, which means it takes an awful lot longer to actually do this problem. So let's just jump right in and take a look at it, because it's fairly straightforward. Okay, it says we have the graphs of these two polar curves, as shown in the figure above. It says they intersect at theta equals pi thirds and theta equals 5 pi thirds, which helps us tremendously, because I don't have to find out where they cross or anything. We're good to go on that front. So pi thirds, 5 pi thirds, we're good to go. Okay. Other than that, fairly straightforward. R equals 4. That's just the regular circle. And then the 3 plus 2 cosine of theta is the one that looks a little bit different. So letter A says it's shaded inside the graph of R equals 4 and outside of the graph 3 plus 2 cosine of theta, which again helps us out. We don't have a calculator, so it tells us that. Write an expression involving the integral for the area of R. So remember, that's just the formula is 1/2 times. It even tells us from where to where we're going to go. So that part's pretty easy. And then we just go 4 squared minus 3 plus 2 cosine of theta squared. And then we've just got d theta. And we're all done. That's all we have to do on letter A. So letter A is not bad because it doesn't want us to find anything. We don't have our calculator, so we just leave our answer just like that. Letter B wants to know, it wants us to find the slope. So in order to do that, what we have to do is we have to go dy d theta divided by dx d theta. Now I know that doesn't seem like a big deal until we realize that y is equal to r times the sine of theta, and x is equal to r times the cosine of theta. The r in question is 3 plus 2 cosine of theta, so I have to go 3 plus 2 cosine of theta. And then I'm going to multiply that by the sine of theta. Yes, we have to use, so we're going to take the derivative of that. So I'm going to go first times the derivative of the second. So I go 3 plus 2 cosine of theta. And then we multiply that by the derivative of the second, which is cosine of theta, plus the second sine of theta times the derivative of the first. The derivative of 3 plus 2 cosine is negative 2 sine of theta. So there's dy d theta. Then I have to do the same thing for dx d theta. It turns out very similar, so I get this, this is times cosine. Everything's the same except we multiply by cosine. So I go first again, 3 plus 2 cosine of theta times the derivative of the second, which is negative sine of theta, plus the second, that's cosine of theta, multiplied by the derivative of the first. So I go 3 plus 2, there's no 3 there. Negative 2 sine of theta. Then we just make a fraction out of it, and that tells us how to find our slope of our tangent line. Then technically all you have to do here, and I'm not going to write it out again, but all I have to do is everywhere that there's a theta, I just put pi halves in. So 1, 2, 3, 4, 5, 6, 7, 8 different places I'm going to put pi halves, and that answer is our correct answer. Now if you were to simplify that down, and there's a lot of simplifying there, but if you simplify it down, you actually get 2/3 as the answer for the second one. That one, again, a little bit rough just because it takes so long to find the derivative of the slope of the tangent line. Letter C says we've got a particle moving along that curve. The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. So it's saying the distance between here and where it's traveling on that curve is increasing at a rate of 3 units per second. So really what that's saying is that is dt, that 3. So dr dt is equal to 3. And that's by far the trickiest part of this whole problem, because what I can realize now is it wants to know the rate at which the angle is changing. So I want to know, basically on this problem, that is the... So you think about this when you're like, what in the world? Because if I take the derivative of this, so if I do dr d theta, then what I get is that part's not that bad, I get negative 2 sine of theta. The problem is it wants to know what d theta dt is. I know dr dt and I know dr d theta, so again, this one's really tricky. What you have to do is you say, okay, I'm going to flip this upside down. I'm going to make it d theta dr instead of dr d theta. That makes this negative 1 over 2 sine of theta, which, again, I don't know exactly why you would be able to think to do that, but when I do that, I've got d theta dr, and then I can multiply d theta dr by dr dt. Again, super tricky. The dr dt's cancel out, and you're left with d theta dt, so I just multiply that by 3. Then I plug in pi thirds. So I get negative 1 over 2 sine of pi thirds multiplied by 3. When you put that into your calculator or whatever, you get negative square root of 3. And the units on that are radians per second. Now again, that one was really tricky, just that last step. Even if you understood what you were doing, it's a related rates problem. That last step was tough, knowing that I could just flip that upside down and it inverses what the dr d theta is equal to. Very tricky problem. Hopefully that made sense. If you have any questions about this one, please let me know.